Okay, B, you're supposed to draw transformation graph. So let's take a look at the first one. Okay, the first one is to draw the graph y equals to fx over 2 minus 1. First thing first, take note there's two transformation. One of it is your scaling, the other one is your translation. Okay, which one to do first? You must always use your replacement to check because we'll tell you which one to do first. Of course, it doesn't matter, but it will affect your unit in this case. Okay, so I'm going to show you the solution over here. Okay, we can actually do my translation first. If you remember, for x, right, we always try to do the translation first. Okay, so in this case, replace x with x minus 1. Okay, which means it's translate by 1 unit in the direction of the positive x-axis. Okay, so check, replace x with x minus 1. Okay, the next one is try to replace x with x over 2. So scaling parallel to x-axis by factor 2. Okay, so please check whether you have the correct unit. Okay, so with that, right, which means your graph, whole thing going to shift 1 unit in the positive x-axis and then followed by scale factor 2. Okay, so allow me to go back to my original graph first. Okay, so everything going to shift right to my positive. So let's take a look at what coordinate do I have. 1 coordinate, 2 coordinate, 3 coordinate. Okay, but there's actually one more coordinate that many of you actually miss out. It's actually the origin. So allow me to always try to write down this. On your own, also make it a habit so that you don't miss out any coordinate here. Okay, so all my x coordinate going to shift to the right because I'm going to plus 1 unit, right? So therefore, change all your coordinate become plus 1 become 2, plus 1 become 7, plus 1 become minus half, plus 1 become 1. Okay, all the x coordinate have changed accordingly. Okay, what else? It says, right, the next steps actually say that the by factor 2. So which means the next thing will be everything multiplied by 2. So eventually multiply by 2 become 4, multiply by 2 become 14, multiply by 2 become 2, multiply by 2 become minus 1. Okay, so this will be what happened to all your coordinate with the y coordinate remain unchanged. Okay, so graphically, agree with me, all my graph have to shift to my right. Okay, so if I shift to my right, okay, at the same time, can you see that I have 3 asymptote? So how are you to find the equation of the asymptote first? Okay, so allow me to go to find equation of asymptote first before I show you the graph. Okay, recall to find equation of asymptote, right? It's always by using replacement. Okay, so allow me to write down my original equation first, or my asymptote. So these are my 3. Okay, so if I go through the replacement, remember I have 2 replacement. First replacement is replace x with x minus 1. Okay, so same for oblique asymptote. Box out your x, so replace x with x minus 1. Okay, the next one that I have is actually my scaling, which I have replaced x with half x. So therefore, same thing, box out your x in this case. So replace x with half x. So this will be the final equation of your oblique asymptote. Okay, now what about the x equals to minus 1? So we do the same thing again, replace x with x minus 1. Okay, which I'm not going to rewrite again, just follow the arrow at the top there. Replace x with x minus 1. Again, I'm going to box out my x, so this is my x. Replace x with x minus 1. Okay, rearrange, you will get x equals to 0. Next transformation, replace x with half x. Okay, again, box out my x in this case. Okay, simplify it, you still get x equals to 0. Okay, now what about the last asymptote, y equals to minus 3? Okay, if you take a look at your replacement, can you see that your replacement only involve replace x? So in this case, your y asymptote will not be affected. Okay, so therefore that's how I get my equation of my oblique asymptote. Okay, so allow me to go back to my graph first. Okay, now I want you to take a look at one very important features. Can you all see that your oblique asymptote has a common point of intersection? In this case, the common point of intersection happens to be minus 1, minus 3. Okay, so graphically what happened? Remember my transformation involved a translation, which the whole graph shift to my left, shift to my right. At the same time, there's a scaling. Okay, so do you think this point of intersection will be affected? Okay, so this is when you take a look at your equation of a final graph. Okay, so in my equation of my oblique asymptote, okay, in particular, this is my final oblique asymptote highlighted in yellow. Do you think all these three will still intersect at a common point? Okay, so let's try to see. Okay, whereby we have x equals 0, y equals to minus 3. So let's try to sub inside this highlighted in pink. So when x equals 0, y equals to minus 3, does it fulfill the equation? In this case, minus 3 equals to minus 3. It does. So which means, right, if we fulfill the equation, all these three should still intersect at the same common point. Okay, in this case, should intersect at 0, minus 3. So check your graph, people, together with your equation of your oblique asymptote. Okay, so check whether you have your oblique asymptote, intercepting at 0, minus 3. Okay, and of course, labeling all your coordinate as well. Okay, okay, so your shape of your graph won't change. It's just a basically shift from my left hand side to my right hand side. Okay, so every other thing else remain the same because scaling won't affect much of the graph. The shape remain the same. Okay, moving on to part 2. Okay, part 2, you are asked to draw the graph of y equals to